I'm here with Mark Aparece, and we are sitting feet away from Lake Michigan. It's too bad the audience can't see what we're seeing and experiencing.
It's really beautiful. I was just telling Rich we should have brought like beach chairs to have our backs against the Lake Michigan, but
That's the next investment for the podcast.
For sure.
It's just like getting beach chairs so we can just be on Lake Michigan and just record all the time. It's a beautiful summer day.
yeah, it's gorgeous out here.
You just moved back from Boston. I've been trying to get Mark on for quite a while. This has been like a year and a half.
Year and a
maybe.
half, 2 years. Yeah. Rich and I
We
actually
go
go
way
way
back.
back.
Yeah.
We were RAs at DePaul University. We were in Monroe Belden.
Yeah.
I
Shout out
believe.
MUB.
MUB. Yeah. Yeah.
This is like 08, 09. Around
Something
there.
like that. Yeah. 08
Yeah.
to 2010, I think.
Yeah.
Yeah.
Wow. And so we're back here
Yeah.
on Lake Michigan.
Mm-hmm.
And so you're a chemistry professor,
Yes.
and that's what brought you back. You're teaching at Northwestern.
Mm-hmm.
You were at Northeastern University
That's
in
right.
Boston.
That's right. Yeah. I moved 7 years ago from Chicago to Boston to get my PhD at Boston College, and then 2 years at Northeastern, and then Chicago called me home, and now I'm back.
So before I want to talk Boston, I want to talk chemistry and science, and also just you in general. But before this, I did look at your Rate My Professor.
For which one?
For Northeastern University.
Okay.
So I don't know if it's a big deal for professors or not, what they're rated or whatever. But you have a 5 out of 5.
I sure do.
Out of 20 ratings, you have 17 5s, 2 4s, and
one
one
one.
one.
Yes.
And one awful.
One awful rating, which
But
is pretty good.
The tags that you have are gives good feedback, caring. We also have in there test heavy. You're very test heavy.
I think that just comes with the subject, with organic chemistry. There's not many essays that you write in those sorts of classes.
The world of chemistry.
Yes.
There were 2 other things on there. Do you know them? Do you check it every day?
Not every day.
Not
Maybe
every day.
like once a week. Just to see if there's anything new.
I was looking for the red chili pepper.
They discontinued that.
Oh, really?
Yeah, they discontinued that. I believe like 5 or 10 years ago. It was an equity thing, because you don't want to necessarily have like professors being rated by their looks, which
That makes sense.
yeah, I'm all for it. I believe when I was teaching at Loyola, right before I moved to Boston, I had a couple chili peppers, and I'm sad to see them go. That's all right.
Yeah. So you have a different profile for each college.
Yes.
So you're starting over at Northwestern.
Yes, sir.
You got to build up. those
Build up my
ratings
Rate
again.
My Professor. It's honestly the only people who go on Rate My Professor are the ones who either really love the professor and or the class, or hate the professor and or the class.
Okay.
There are official avenues through universities where students can actually give feedback, more detailed, more metrics, and those are usually more reliable. But I'm happy to report that my official reviews have been pretty good too.
Pretty positive.
So, yeah.
Pretty positive.
Yeah.
All right. So you're in Boston. Tell me about Boston and your time in Boston. Because we're like Chicago cats.
Yes.
So now you're in East Coast territory.
Yeah, exactly. Boston was a nice place. It was hard to move away from Chicago.
Okay.
This is my home. This is where all my friends are. Most of my family's here.
Mhm.
But part of me felt like I needed to go away, at least for a little bit. I think the goal was to eventually move back. But Boston was an interesting town. It's much smaller than Chicago, but there's a lot of history there. A lot of amazing green spaces, just like Chicago. An okay transit system. But I basically spent 5 years at Boston College, like I said, which is not in Boston. and it's not a college. It's actually technically in Chestnut Hill in Newton, which is a suburb, and it's a university. So lies all outright. But yeah, I spent 5 years there working in an organic chemistry research lab. Published 3 papers, did a lot of teaching there too, which is something that I'm much more focused on. Obviously, I actually don't have a research program at Northwestern. I'm just, I shouldn't say just, but it's my official title is Assistant Professor of Instruction. So no tenure, no research lab to speak of. So all I do is focus on the curriculum and teaching the big classes that research professors don't want to do. But yeah, BC was very good to me. Boston has been very good to me. I grew a lot. I think I grew up a lot, discovered a lot about myself.
Yeah.
I discovered, one, I don't want to do research.
Explain to me, there's a couple things on my mind. What's the difference between a college and a university?
A university is more research focused. It's also typically bigger than a college. So when I think of the word college versus university, colleges are usually smaller, more undergraduate focused than having master's or doctoral programs.
Okay.
Mm-hmm.
Universities are the research.
Yes.
Okay, so then go elaborate on Boston College and then teaching and where you're at now.
Sure. Yeah, so at Boston College, got my doctorate, 5 years spent in the lab doing organic chemistry research. I also got the opportunity to be a teaching assistant for a few classes, and I really missed that about being in graduate school, because when you get a PhD in a science, you're not taking classes, and ideally you're not teaching because you want to focus on your research, get your research done, publish, and get out.
Okay.
But I knew that I really wanted to teach. That's like my heart and soul. I love doing it. I love communicating science. I love telling my students fun facts about the things that they're learning that's applicable to real world.
That was another thing on your Ray My Professor was like something about teaching or lectures. Mm-hmm. Great lectures. That's great lectures.
I don't know what it is. I've been told I have a knack for just delivering things in a quote unquote very clear, direct, no nonsense kind of way.
Okay.
Which I'm not quite sure I guess a lot of students have been giving me good feedback about that, but I don't know. I just sort of do it.
You just got it.
I just got it,
just
apparently.
Got it.
Yeah.
Okay. Elaborate more on... because I have a friend, Dr. Dave, who teaches history at UIC, and there seems to be this kind of not tug of war, but that's not probably the right phrase, but there's like teaching and then there's research.
Mm-hmm.
And some people don't like doing one or the other. It seems like you're leaning more towards teaching and being with students and being able for them to like understand the material and curriculum.
Mm-hmm.
Yeah, what's your perspective on kind of the research versus teaching?
So what I have been doing at Northeastern and what I hope to do at Northwestern is to buzz market some of my colleagues' research.
What is that word?
Buzz market. I learned that from another podcast, Judge John Hodgman podcast.
Okay.
Where he basically will just drop in like a product, like we're buzz marketing Brooklyn and sheets, or some coffee company. But I guess in the context of university research, I'll like to give a plug to one of my colleagues' research programs, which ideally would have a lot of overlap with what they're learning in the lecture.
So it's like this collaborative effort between research and teaching, right? Teachers are taking kind of ideas from the research that's happening, and then... something like that?
In the traditional organic chemistry curriculum, it's probably more the other way around, where we basically teach the sophomores the basics of organic chemistry, and then once you get into the research lab, then you learn, a lot of the things we taught you, that was actually from things from 20 years ago, maybe 50 years ago. Here's more modern techniques that you learn in a research lab, even though all the stuff that you do in a research lab will still be undergirded by very few rules and fundamentals in chemistry. And I think that's one thing, going back to the great lectures quote that people have been giving me on Rate My Professor, is I will often repeat certain keywords and just emphasize how common a lot of organic chemistry processes are. Like if you learn something from chapter 6, it's going to be the same from chapter 12 and chapter 14. Like it's all fundamentally the same, even though it has different clothes, if you know what I mean.
Okay.
Kind of hard to explain to a lay audience.
Well, let's try. We've been talking about universities and research and stuff.
Mm-hmm.
What is organic chemistry?
So the textbook definition of organic chemistry would be, it's the chemistry of carbon-containing compounds. And carbon has very special properties that gives it a lot of versatility, which is why carbon is the backbone of all living things. But in the first lecture, when I talk about what is this class, what is this subject, I say carbon is just the backbone. It's more of the things that decorate the carbon backbone. So other atoms are actually just as, if not complementary to what carbon can do, like oxygen atoms, nitrogen atoms, chlorine atoms. Those actually give organic compounds their properties, their behavior. And carbon itself, if it was just like a straight chain of carbons, those don't really do much. It's the stuff that decorates the carbon that gives it its properties.
So the carbon itself is very essential, but it's not necessarily what makes things special, right? It's everything else that kind of adds to the carbon?
Yeah,
Okay.
I'd say so. Mm-hmm.
This is wild. I remember in college, you just have you have your notebooks open and I see what's in there, and you have all these, I don't know if they're doodles or whatever.
They're doodles.
Of like all these different compounds and chains of periodic elements.
I tell my family
elements of
and
the
friends a
periodic
lot
table.
that I got a PhD in polygons and zigzags, because you just draw hexagons and zigzags a lot, but those all represent organic compounds.
See, to me, that was like what those drawings were,
Mm-hmm.
and what they looked like. It looked more foreign to me as like a language than like any language I've seen on earth, like written. Like to me, that was so foreign, and like I was someone, really until recently, I was supposed, like I wasn't really into science.
Mm-hmm.
I wouldn't say intimidated by it, but it was just like it didn't suit my personality, or like I'm not someone who's like gonna be super detailed and spend all this time. I always wanted to be a paleontologist, but like the amount of time it takes and detail oriented, that's not me.
Mm-hmm. Mm-hmm.
So in high school, I took my science classes requirements to graduate. I finished them by my sophomore year, so I wouldn't have to deal with them again.
Sure.
And I'm getting more into it now, and just like learning about all the cool things that can happen
Absolutely.
with it. I don't know, I guess there's like that appreciation that everything in the world is made up of atoms, and it's all about how they're assembled that make them what they are. And I've talked to I love talking to people in like the STEM fields, because they're like building the world.
We're building things on a molecular level, which still kind of blows my mind.
Yeah.
And the fact that we can reliably say, oh, I connected this atom to that atom, is pretty humbling and also inspiring at the same time. Back to your comment about how it's a language. It's actually a very common description of organic chemistry, because
Okay.
just like in any language, like a spoken language, there are rules. There's syntax. There's a grammar, and there's a very similar uh, analogs to the way molecules behave. Right? There's a grammar to how they behave.
Okay.
They this one type of atom will interact with this other type of atom, not with this other. A will react with B, not necessarily with C, and there are rules that you can use to predict that. And there's a vocabulary in organic chemistry, and of course there's a lot of art too, because as you said, there's a lot of drawing, a lot of doodling. And what attracted to me the most about organic chemistry is the fact that in many ways it's very much like an art. At least when you draw it out on paper,
Okay.
it looks, at least to me, it looks visually impressive because it's just diagrams and hexagons and zigzags. And can I curse on this podcast?
You can say whatever you want.
All right. I'm going to sound like such an asshole, but I feel as though deep in my soul I'm more of an artist than I am a scientist.
See, I think a lot of scientists feel that way about themselves.
Yeah?
Though.
You think so?
I think it's all like art is so ambiguous in a way. Art is just like a craft in a sense,
For sure.
and like a beauty in the result of this craft, where we oftentimes look at painting, drawing, sculpting as like art, but I think it's only like culturally that we define it but that way. But like broadly, architecture, there's art in how things are structured, assembled, the materials that go into it. It's like this
Poetry, literature,
poetry,
music.
Yeah,
Yeah.
it's very I get that. Two things. Organic chemistry. What other types of chemistry is there? And two, what is the like utility and usefulness of organic chemistry? How it's used?
Sure. So there's also inorganic chemistry, which is, so if organic chemistry is the chemistry of carbon-based compounds, inorganic is everything else. So things like metals, things like silicon, boron, iron,
Okay.
palladium. But there's a lot of crosstalk between organic and inorganic chemistry. In fact, all the fields. So there's another field that's typical called physical chemistry, which is discussing how molecules behave in terms of their energy. So how fast a reaction goes, that's called kinetics. And the stability of, let's say, you start with A and A gets converted to B, there's an energy difference between those, and that's called thermodynamics. And there's also quantum mechanics, which is, an amazing 20th century innovation and the most accurate theory that exists out in science.
Okay.
It's just extremely
I want you to
mind-boggling to
elaborate
me.
on quantum theory, quantum mechanics.
Sure. So basically the start of quantum physics is the observation known as the ultraviolet catastrophe. I forget which scientist observed this, but the prediction was, oh gosh, I really should have reviewed what the ultraviolet catastrophe was, but basically the idea was if you kept shining light onto something, it would absorb all this energy, and eventually it would just keep absorbing energy into the ultraviolet, and that would, of course, break the laws of physics. Whereas the prediction was it would just keep absorbing energy, whereas the observed data show that it actually didn't. And another interesting thing that kicked off the quantum revolution, so to speak, was the
And this
fact
is like in the
that
1920s ish.
around the turn of the 19th century, yeah.
Okay,
So
yeah.
more like, around 1900, 1910.
Got it.
There's another. So quantum actually means a small unit,
Yeah.
and the reason why it's called that is if you think about energy levels in an atom, they actually have very set energy level. So you go from so the analogy that is often used is you have a ramp, which is continuous, versus a set of steps, which is discrete. And when you walk up a set of steps, you go from step 1 to step 2 to step 3. You don't have a step 1.5 or a step 1.25. It's always going to be 1, 2, 3, very set energy levels.
Okay.
Which is what happens when you go really, really small. So when you have an atom and it has these electrons orbiting around the atom, the electron will occupy an energy level called 1, and then when it absorbs energy, it'll go from 1 to 2. It does not go from 1 to 1.5 or 1.75. And that puzzled a lot of scientists, because if you think about the macro world, so what we call classical physics, right? If you roll a ball down a hill, right, that ball you can measure or you can predict what energy it would have as it slowly rolls down the hill. Not so when you go down to the atomic level. So that was one of the weird things that people observed about the quantum world, and I don't know how much you want me to go further.
Well, back in February, I read this Introduction to Quantum Theory book by John something.
Okay.
Wish I remember the name. It's like an orange book, pretty small, but like the gist of it, what I got out of it was like they mentioned classic physics, and you know all these ideas are progressing throughout the century since the scientific revolution, and they're getting to this point where they're doing these experiments, and they're like their minds are being blown.
Yes.
Like they're not what should be observed is not happening. It's like this like like it
what also another thing that quantum theory introduced into, I think, physics was the idea of uncertainty. And I think that before the 20th century, and even now, like a lot of scientists, and even people who think about science, they say there's a certainty to things.
Yeah.
There's a correct answer, there's a fact, and there's things which are wrong, right? But with quantum theory, what it introduced into science, I think for the first time, was this idea of uncertainty, and I think the extension of that is chaos theory. So, for example, let's go back to the idea of the ball rolling down the hill, right?
Okay.
If you're looking at the ball rolling down the hill, you can determine both its speed and its position, right? Because the light packet, our photon coming from our eye is observing the ball rolling down the hill, or rather the photon bouncing off of the ball is going into our eye.
Yeah.
And we can determine how fast it's going and where it is. When you go down to the tiny level, the atomic level, a photon and an electron have approximately the same size and energy. So when you have a photon that's hitting an electron, you can measure its position, but because they have similar sizes, you will affect its speed and vice versa. So the thing that quantum theory introduced is something called the uncertainty principle, where if you know how fast a subatomic particle is going, you know less about its position and vice versa. So we discovered a limit to what we can know about the universe, which, of course, back in the turn of the 19th, 20th century, people didn't like. They didn't like that there's actually limits to how much we can know. So I think back in the time of Newton was in favor of this very mechanical clockwork universe, where if you put all the planets in their positions on the moons, the sun, and you said all of these celestial bodies have this position and they have this much energy, this much speed, you can predict in 10 years, in 100 years, in 1,000 years where everything will be. But it turns out that there's a lot of uncertainty in science, and it's not quite so clockwork as we thought it was. And so probability actually plays a big role in chemistry these days.
So correct me if I'm wrong, but like
Mm-hmm.
in quantum theory, it's like multiple things can happen
Mm-hmm.
at the same time.
Until you observe it. So you probably heard of Schrodinger's cat.
Yeah.
Yes. So the idea.
Schrodinger's cat.
So by I think it's Erwin Schrödinger. He was one of the big proponents of quantum theory, and they basically had to invent new math to describe what was happening at the quantum level. But for those who aren't familiar with Schrödinger's cat thought experiment, let's say you have a cat in a box, and there's some poison in the box. And this is a thought experiment, so no animals were actually harmed. But basically the poison, the container for the poison could open or could not. And if it opens, the cat's dead, and if it stays closed inside the box, then the cat is alive. And you don't know whether the cat is alive or dead until you open the box. So you say, oh, the cat is both alive and dead.
Yeah.
Until you open the box and you say, oh, the cat is actually dead. Or you open the box and you say, oh, the cat is still alive.
Yeah.
He actually came up with that thought experiment to throw into the light how absurd quantum theory is. Einstein did not like the implications of quantum theory.
Didn't.
Schrödinger did not either. Like, it gave them chills up their spine, and it's kind of giving me chills too. Maybe it's just the wind, but it's just like the fact that they're saying like what does it mean for a cat to be both alive and dead until you open the box and the act of observation, what we call collapses the wave function, collapses the two possibilities into one possibility.
Okay.
So that's what's happening actually at the quantum at the atomic level.
And I heard like the term like God particle sometimes in
That
quantum
is
theory,
more
or
like
no?
subatomic physics, like even below the level of the atom. So like the nucleus is actually made of protons and neutrons, but then even those are made of things called quarks, which are even more fundamental particles.
Quark spelled with a Q, right?
Q, yes.
Yeah.
And there's different, what they call flavors of quarks. Scientists are weird. There's like a top quark, a bottom quark, charm quark. I don't know. That's actually, to be quite honest, beyond my expertise, the subatomic particles, because that's more like particle physics.
Let's get back to chemistry.
Sure.
All right. So we got all these different kinds of chemistry.
Mm-hmm.
You're studying organic chemistry. Right. What is like the utility in applying organic chemistry? Like what examples out in the world can we imagine?
A lot of examples, quote unquote, real world examples that I give my students in class, in addition to just the raw material that they give that I'm giving to them, is examples in biochemistry and medicine. So a full year of organic chemistry is usually the prerequisite to take biochemistry, because, like I said, the fundamental patterns and rules that molecules follow apply to us too, apply to our biological systems. So I give them a lot of examples of this is something you'll see in biochemistry. It's just a fancier version, a more elaborate example of what I'm giving you, like in like the sophomore level organic class. Medicine, so a lot of drugs, they follow organic chemistry principles.
Drugs, hell yeah.
Yeah, medicines and otherwise, yeah. Everyone loves the chapter on nitrogen-containing compounds, because that's where you talk about neurotransmitters and methamphetamine and like all these really these drugs, licit or illicit, and everyone just perks up. Everyone loves learning about drugs. I've found.
Because drugs are chemistry.
It's very interesting. Yeah, it's really interesting to learn about, and at least to me, and I think most people.
So you have the theory, and then you can have the observed part with it.
Sure, yeah, you can say like here's Yeah, like we're gonna we're gonna design a drug. So back to what you asked me about what you can do with organic chemistry. A lot of people I graduated with from Boston College, they work in pharmaceuticals.
Okay.
They work in biotech. So Boston Cambridge is a huge hub in the nation for pharmaceuticals and biotech. So Merck, Novartis are there.
Okay.
Another field that people go into with a degree in organic chemistry is material science and polymer chemistry,
Okay.
which is actually a really huge deal because if you think about paints and plastics, things like that, that's a lot of organic chemistry. And the big secret, open secret, is that most people with an organic chemistry degree don't actually work in the big pharma places. They actually work in material science, like helping design new polymer formulations and coatings and things like that.
Wow.
Yeah.
Yeah, I started learning about a couple things. I'm very curious about biotechnology,
Mm-hmm.
and it seems like so I read this book Homo Deus like back in 2018,
Mm-hmm.
and it's about like a brief history of the future of humankind. It's by Yuval Noah Harari, who wrote *Sapiens*, which is like a brief
Mhm.
history of humankind, and that's what really, that book right there got me like invigorated into like the future and science and technology. I would definitely credit that. And it was like, I've always kind of been this like romantic kind of person, the past and blah blah blah, and I was like, oh, it was like an ass kicking. I was like,
Sure.
oh shoot, like I gotta learn about this stuff.
Yeah.
And
definitely.
what he kind of argues is that at the top of the human agenda now is kind of humans want to live healthier, longer, and happier. So a lot of decisions and technology and investment is going towards that, which merges kind of biology and technology together, right?
Sure, definitely. Yeah. So like for example, drug design is one field that a lot of my former colleagues have gone into, and just trying to find like the next blockbuster drug for Alzheimer's or you name it, cancers, right? Like.
So what is the? Yeah, I think for me, like I get a little confused with the term pharmaceutical, big pharma, drugs. Like, it seems like there's this. It becomes very like opaque. Like I don't know if like I see drugs pushed during commercials all the time,
Right.
and at the same time too, I know that there's so many drugs for treating cancers and diseases and things like that, where it's kind of seems very gray as far as like ethics, I think.
Yeah, definitely. I think the word drug gets a negative connotation,
Yeah.
right? When you think of drugs, you don't necessarily think about Tylenol or ibuprofen. You think about meth or cocaine or marijuana, and pharmaceuticals. You think of Tylenol and molnupiravir, which is the over-the-counter COVID drug, which I talk about in my class. But as you said, with the opaqueness to things, with oxycodone, that's a pharmaceutical, but it's abused, right?
So it's really like a lot of the gray area is like these drugs are effective,
They're effective. Mm-hmm.
but then if one abuses them, then it becomes a problem.
I'd say so. Yeah, like marijuana, like THC is. I mean, 20 years ago, people would call that a drug, but now people are starting to open their eyes to the fact that it can help with nausea, it can help with appetite, it can help with calming anxiety, which sounds like a pharmaceutical, even though it comes from a plant. Psilocybin, which is in mushrooms, like there's a lot of research now that talks about how it can be actually therapeutic for a lot of people, even though it's like marijuana and mushrooms and other things which are quote unquote abused and criminalized actually have a lot of worth to give to a
Yeah.
lot of people.
I've definitely noticed that recently is like this deeper conversation on the potential helpfulness of things like psilocybin, things
Mhm.
from mushrooms and psychedelics, I
Yes.
guess,
Mm-hmm.
to treat certain things.
One of the, I believe the Nobel Prize awarded, I believe it was 2018. I don't remember, but it was this woman called To Yu, who was a Chinese chemist, and she actually helped isolate a lot of the active organic compounds in traditional Chinese medicine.
Okay.
And that was sort of a meeting between what we call Western medicine and what's pejoratively called folk medicine or everything else. And I think a lot of people are starting to realize that, there's a reason why these cultures have over time developed these medicines, these quote unquote folk medicines, because they work, right, for the most part. And I think people are starting to look to inspiration toward the natural world, like psychedelics in mushrooms and marijuana and traditional Chinese medicine and other traditional medicines around the world. And we also see that kind of in popular culture with, oh, is this apple organic? Is this
Yeah.
non-GMO? And I think I credit that to a lot of growing distrust of science. So, for example, leaded gasoline and the chlorofluorocarbons, which have destroyed the ozone layer, and all these microplastics, which exist now everywhere. It's in rainwater, it's in our bodies. So I think there is a push against what humans have made in favor of things which are natural. And of course, there's nuance to that, right? The poison hemlock plant is natural. I wouldn't drink it, right? That's the plant that killed Socrates. Or Tylenol or aspirin. People take those every day, with very minimum side effects. So there is nuance to that. But I think, yeah, it's very interesting because you mentioned about the book Homo Deus and how STEM fields are going to help humanity advance through the next centuries. And yet there's a lot of people going back to tradition
Yeah.
and trying to thinking retroactively or retrospectively as well, which is a very interesting phenomenon.
Do you have like a personal philosophy on drugs or prescription drugs? I think I lean towards like I try not to mess with my body as much. Like I prefer to just be, or like I think in my life my approach is like I want to delay having to like have prescriptions
Sure.
or like relying on prescriptions as
Mhm.
long as I can.
For
in
sure.
a sense.
Definitely.
I don't know.
It's very multifaceted, and
Yeah.
I think it comes down to, and of course it's very simplistic, but trying to take care of yourself. Like you said, try to delay how much reliance you have on unnatural things.
Mhm.
So, for instance, in grad school, I gained a bunch of weight, as you do, because you're just stressed and you're eating all the time and you're in the lab and you're just in lab 6 days a week for like 10, 11, 12 hours, and you don't really have time to like cook good food or to even be active. At least I didn't. That was low on my priority list. But then I started really taking care of myself, lost a bunch of weight. Like I said, in Boston, I discovered running. I love running. I ran yesterday.
Yeah, you're a big walker too.
I love
we both
walking.
we both
Yes.
walked to this location. We're both big walkers. Yeah.
And walking is actually like a really healthy and relaxing activity. It's a good alternative to
Yeah.
running, which I heartily support. But yeah, I started eating right, started getting more active, joined a gym, and I found that my asthma got under control. My
Really?
allergies got under control, which was very surprising to me.
Huh.
And I think part of it was just me running outside, getting exposed to like all the plant matter that's floating around. And yeah, just taking care of myself really helped me wean off of having to rely on like Zyrtec and my albuterol inhaler, which of course is simplistic. If you have cancer, right, no amount of walking is going to put your tumor in remission, right?
Yeah.
So of course there's drugs out there that do help with
Yeah.
combating cancer. But yeah, like I really like what you said about just like relying less on like prescription drugs and just trying to take care of yourself and to the extent that you can or your body can.
Yeah.
Like a lot of people take baby aspirin every day for to help with blood clots and heart health, but how much of that how much money could you save by just going on a walk every once in a while and losing 5 pounds, right? Rather than trying like relying on drug to keep your heart health healthy.
Yeah, that will be a really interesting ongoing cultural society discussion.
Mm-hmm.
Certainly in America, where we have such a reliance on cars and driving and but like the health of our hearts and things like that. Switching gears a little bit, the other thing I wanted to talk about was material science.
Sure.
So I didn't know. I have people on the podcast from like all over in all different fields, and I met these material scientists in Istanbul. So these 3 siblings, the Mansours, shout out, Mubashir, Maya, and Miriam, and our conversation back in February just blew my mind. Of like, I went in, and a lot of times I'm familiar with some of these topics,
right?
In sciences and fields. Material science and engineering, I knew very little about, and it was just like I woke up that morning with like a certain perspective on the world.
Sure.
And then after that conversation, it was like, whoa!
Yeah, definitely.
Everything in the world is materials.
What we're sitting on right now, someone formulated this to be the correct density, the correct weight, the correct, erosion resistance. Like a lot of our world is designed, and it's a really, like, I do occasionally step back and think about how much is just designed, like hopping on the train and making sure that like the train doesn't fall off the rails or things are going on time, or the fact that I have drinking water, or I live in a building. I live on the 8th floor of a building that doesn't fall over. There's a lot of things that I think we take for granted and we just don't think about. And there's people like everything. Someone did this. Yeah. Right. Or a team of people did this.
It's so incredible.
It's really incredible. Yeah. Yeah. Like back to material science. Speaking of concrete, if you go to Rome, right, all of their old classic architecture is still there, and it's survived so long. And then you think about the concrete that we have here, it's like falling apart. So I think a lot of the recipe that people are trying to follow is like, add this water, and people are trying to add fresh water, but what the Romans didn't specify was you add seawater, because when they say water, they just go water, as in water from the ocean, and that actually the salt actually helped make a durable product, like all the columns that we have. So there's a lot of uncertainty to what the ancients did that like endure when the stuff that we make now doesn't endure.
So what kinds of things excite you about material science right now?
That is definitely a field that I don't know very much about, but I am actively trying to learn more about. Okay. Because like you said, it undergirds our everyday life. So back to like the science of organic chemistry. When you make one little tweak, like you substitute one atom for another, or one atom for a group of atoms, or one group for another group, like you can drastically change the properties of that molecule, whether it's going to a material, or it's a drug, or it's a biomolecule. So when you think about polymers, so commonly called plastics, right? If you have polyethylene, that's like Ziploc bags. But then you substitute a hydrogen for a chlorine, you make polyvinyl chloride, PVC, and that's a completely different material, right? A PVC pipe is much different from a Ziploc bag, and all you do is you just change a hydrogen for a chlorine, or you change that chlorine, you substitute that for something called a phenyl group. That's polystyrene, and that's styrofoam, right? Like the takeout boxes that you have, and yeah, like these tiny minute changes can affect so many different things. And of course, like, it's not just mixing things together. You have to add plasticizers to make things like kind of move better. You have I forgot what this other thing called, but to make it maybe more rigid. So you can add additives to sort of modulate the properties of your material, which is like super interesting. Yeah.
Man.
Vulcanizers, that's what it is.
Okay.
Like, yeah, with
Vulcanize.
tires. Yeah.
Great word. Kudos to the scientists that came up with vulcanized. It's a great word.
It was something to do with tires. I think adding a little bit of sulfur made the rubber tires that we have on our cars possible. Because before adding sulfur, it was just, it would wear down very quickly. It was very floppy. And then just adding a little bit of sulfur made it the rigid black tires that we have on our trucks and cars.
Nice.
Yeah.
Couple things just on my mind real quick. Sure. I was out in the Southwest not too long ago, within the last month.
Yeah, you went to Vegas, right?
Vegas and like Page, Arizona, Utah, all over there. And conversations were a lot about water scarcity. And so what's kind of your perspective on water scarcity and real briefly, like, potential solutions for kind of this problem that certainly the Southwest is facing?
Definitely. What actually opened my mind to that is a book I read a few years ago called The Life and Death of the Great Lakes.
Okay.
By Dan something. I can't remember the it might be the Death and Life of Great Lakes, whatever.
Okay.
But basically talks about how in the future the Great Lakes of North America are going to be a huge source of fresh water in the coming future. And how even in Wisconsin, I know you're from Wisconsin, I believe there is a town that sits just to the west of the natural watershed.
Okay.
So this town, their water would naturally flow west toward the Mississippi rather than east toward Lake Michigan. And they've found a way to just sort of get over that and try to get water from Lake Michigan, which caused a big controversy. And there's a lot of people are trying to divert a lot of the fresh water here to places like Georgia, which is a huge project. And of course, so back to the Southwest and California, like it's a little scary.
No, it seriously was scary when I was out there. So I'm looking at snowbird locations. I'm scouting, observing, and I've been to Miami twice.
You're like my age. You're like 32, 33.
Yeah, I'm going to make it happen very quickly.
Sure.
And so I'm already spending times in these locations, and I'm like, do I want more southeast? Do I want southwest? What I concluded was I dig Miami, especially because of the culture, the energy, the vibes.
Mm-hmm.
Southwest, it was so chill. Everything's so spread out, and you can see canyons miles away. You can see weather storms miles and miles away. But the water scarcity thing really freaked me out.
Yeah. And I think the water scarcity problem is going to be a problem even in a place like Miami, where, there's water, but you can't drink it. And there's a lot of people are trying to set up infrastructure to purify the water, and things are just getting more polluted. So even though you could be surrounded by water, but it might not necessarily be potable.
But this is what I don't understand. How do we not have this technology yet? Or, like, how do we not have the, like, technology or resources effective, the level of effectiveness to turn salt water into fresh water? How have we not gotten there yet in society?
I know
Civilization.
there are certain groups that are trying to, and certain companies that are trying to develop that technology, and I believe to an extent they're
Is it like
they're getting a
politics
lot
and
of-
energy get in the way?
Yeah, like everything else, politics. Like,
But this seems like a good thing that we should probably look into.
look, there's a lot of good things that are good for humanity, but when have politicians had our best interests at heart?
Well, now I'm like putting my foot down. I'm very protective of this water right
Yeah.
here. We got a Great Lakes, folks. We got a
During the upcoming apocalypse, the Great Lakes are a great place to be. I am
Yeah.
not moving from here.
yeah.
I need my fresh water.
People are afraid of the cold, so they go to the southwest, southeast.
Mm-hmm.
Meanwhile, we're just waiting, for everybody to come back because we got the
Yeah.
water.
Yeah, and the global south is going to be affected the most with climate change, like
The southern hemisphere.
more toward like the equator areas. So like the areas around the equator are just going to be basically unlivable. Like
Just
temperatures
scorched.
are going to be so hot, and it's not just the temperature. It's the humidity. I forget what the actual number is, but
Okay.
above a certain percentage humidity, you can't sweat anymore. Sweat is actually how our body cools ourselves, because like when we have our sweat come out of our pores, it's the evaporation of the water from our skin. That evaporation is taking away the heat from our bodies. And there comes a point where if it's too humid out, the evaporation of the water from our skin just won't happen. So we can't actually sweat away the heat energy from our bodies. So people will actually overheat without AC. And
Yeah. So
and-
then,
yeah.
so there'll be this like astronomical reliance on AC, which
Mhm.
requires energy
Right.
to run.
Right.
Hmm.
And a lot of climate refugees. One could argue, there's another book that I recently read. By the way, I know you like to read, I like to read, and you want to come by, look at my library. There's a book called
I would love that.
Rising by Elizabeth Rush.
Okay.
She actually talks to a lot of people in the U.S., people in Maine, Rhode Island, Staten Island, Louisiana, and San Francisco, just about rising sea levels. And she argues that like one of the first climate quote-unquote refugees are people in Staten Island who got hit by Hurricane Sandy. Like they had their beach houses, and they decided that they're going to take the government funding to move away from the ocean and just let it go back to being wetlands.
I do see
Yeah.
that. I haven't talked about it really publicly, but this is something I kind of believe a lot. And that's the 21st century is going to be about human movement.
Yeah.
And like the populations, I closely watch like the populations of countries and areas and continents and look at like that data and like trends. And it'll be really interesting the moves that countries make to like take in people, absorb people, and then put people in positions where they can still live and be happy and
fulfilling
productive,
lives.
live lives.
Yeah.
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 And so like human population movements. I think the 21st century is going to be really it's going to be a big issue.
One of the most hard-hitting points that this author made is that people are so slow, if not inert, to act on climate change is because it just takes so much time for you to see, a rise in temperature, 1 degree Celsius per, like for however long it takes. So because it's not an immediate threat, people just look the other way.
Because people also too on a daily basis have struggles and
Yep.
needs, and
like I gotta go
it's
to
very
work.
tough.
I gotta
Yeah.
pay my taxes. I gotta pay my rent. Like no
Yeah.
one's if it's something that's gonna happen in 20 years, like no one's gonna. People are not acting on it, which
Yeah.
is a fault of our species.
There's so many directions to go.
Sure.
Real quick, microplastics. You had mentioned
Mhm.
it. I listened to this interview with someone I think who helped design. I don't know, someone in Silicon Valley, but was working on microplastics and technologies to remove microplastics from the atmosphere. What's
Interesting.
what's your take on, not take, what's your perspective on microplastics and like help me better understand it?
So with plastics in general, the reason why they were so lauded when I believe in like the middle of the 20th century is because was how durable they were, right? You no longer had to rely on glass, which could break, or wood, which could rot. You could put things in a plastic container and it would be durable, and it was its durability which also led to people having a pushback against it, because they said this red Solo cup is not going to decompose anytime soon.
Yeah.
Right? That wrapper that you throw out of your car is going to be there for the next 100 years. And of course, it does break down, but not into anything that is actually renewable, right? So like if you take polystyrene, it's going to break down into smaller units of still polystyrene. That's the microplastics that you talked about. So it's just like the really tiny fragments of the styrofoam cup that they're now floating around and maybe in our blood. Trying to cleanse that from the environment that might. I mean, I know there's a lot of skepticism about science because it brought us into this conundrum, but a lot of people are trying to, find solutions to right what has been wronged, and I believe people are trying to make these meshes. Some of my colleagues at Northwestern have talked about these called MOFs, metal organic frameworks, which could help block or trap these tiny compounds. And I think there is technology, nothing with microplastics, but more with pollutants. I believe in certain cities, there's a special paint that you can just put on like the side of a building or like on a column in a freeway, and it will just suck up the carbon dioxide or the nitrogen oxides that are just floating around. And it's just like, all you need to do is just like put in a fresh coat of paint, and it'll just absorb the pollutants, and then every few months. So I'm optimistic, seeing what we've been able to do with those pollutants absorbing paints, and also with solar panels. There's been a huge incremental increase to solar panel technology. It used to be not very efficient. We're getting there. Okay. So I'm pretty hopeful about cleansing microplastics from the air and the environment.
Yeah. Well, we're kind of wrapping up here. Sure. Before we go, I do want to talk a little bit more about Boston and Chicago.
Sure.
So again, how would you describe your experience in Boston? And how's it feel coming back, and what do you love about Chicago?
Like I said, Boston, I learned a lot about myself in Boston. And I grew up a lot there, not just getting a degree, but, personally. And I just became a lot more sure of myself. And yeah, but Boston's really nice. I'm not gonna dunk on Boston. It's just, very small, at least for me, hard to make friends there, but I think that's true for anyone. Like when you're an adult, like all my networks here, and I'm a pretty introverted dude. I think I can, right? Would you say so? I'm pretty introverted. It's just hard for me to
I think generally, and then then you're
then you get me to talking, and then I can't shut up. But, but which is amazing that I'm a teacher. But, it was just really hard to make friends. I didn't really have a connection to Boston. Whereas here in Chicago, this is where I did a lot of my own self-discovery in college, and my master's degree here, and making friends who are my age, who we could all kind of be lost together in our 20s and
Yeah.
kind of grow together. And like it's more of a depth of connection that I have with the people of Chicago that brought me home. Boston's great. Like I recommend you go visit there. Also, a big thing that precipitated the move. That's a chemistry joke. Huh, precipitate. But precipitated my move back to Chicago is it's really expensive there.
In
like
Boston?
The rent, like I couldn't afford it. There came a
Really?
time when I was just like, I can't throw away half my paycheck to rent.
Wow.
Yeah, and it's that Boston, San Francisco, New York. I talked about this with my friends. Like, I love New York. I could live in New York. I can't afford to live in New York.
You
But-
could live in New York, but you couldn't live in New York.
No, you'd live there, and but what's your quality of life, right? If you're hustling and you're living in a one bedroom that's like the size of what could be like a studio here in Chicago. So yeah, like Chicago's great. Everyone sleeps on Chicago because it's not a coast,
Yeah.
right? Everyone's like, oh, it's not L.A., it's not New York, it's not Boston. What's
Yeah.
there? And then people come visit, and they're like, this is a fun, great city. So
Yeah. It's I think it's like the most bang for your buck
yes.
for big cities in the United States and probably the world.
It's huge. We have a great public transit system. There's many different neighborhoods with different personalities.
Mhm.
Great food, great lakeside. Like we have great
Yeah.
park system, not just along the lake, but in the city. Winters are brutal, but I came from Boston, so it's the same. So if you can withstand the winters, the summers are beautiful here.
Yeah.
Yeah, it's walkable. Well, everything's walkable for
Yeah.
us.
Yeah.
I once walked from Edgewater to Wicker Park and back, which is a total of 17
Wow.
miles, and I was like, well, like it's hard.
Wow.
Yeah,
And don't forget, we live on a great lake.
we do live on a Great Lake, and I think what people don't appreciate about the Great Lakes, they're seas.
Yeah.
They're inland freshwater seas. They're gigantic.
I cannot see lands the way I'm looking right now. It is endless, boundless.
I had people who would tell me about their first visit to Chicago. They said, "Yeah, Lake Michigan. I thought it would be like a cute little lake." It's like
No.
it's a sea. It's an inland sea.
Yeah.
Like it's gigantic. So
Shout out to the glaciers.
thank you, glaciers, for carving these Great Lakes out.
Well, Mark, thank you so much for sitting down and having
Thanks
a
for having
conversation
me.
with me.
Yeah,
It's
it
been
was
great.
Great to catch up.
Absolutely.